Okay, so we're back with another board. This is an 820-3437, and we'll focus. There we go. And the problem with this one is there's no MagSafe light. So no MagSafe light, no fan spin. However, we do get a PP3V42 rail. I think that's there. There we go. So we get 3.44 volts on that rail. So do the usual thing, we'll switch over to the microscope and do a quick once over on the board and see if we can find anything that's obviously wrong. And we're over on the microscope. You'll probably notice from previous videos that I've uploaded, the image is looking a little bit more crisp. Turns out the lens facing the rework area has gotten very, very filthy, and I cleaned it up and it's like I've got a new microscope. So yeah, apologies for that. So just having a look around the board at the moment. So that's the mezzanine connector that goes over to the right I/O board. Sorry, left I/O board. That all those pins look good. I usually check here first when I've got 3v4, but there's no MagSafe light coming on, which usually means that the one-wire signal isn't getting through. So that's one of the low-hanging fruit to check. It looks like this board may have been reworked at some point. There's evidence of flux residue on the board, and also interestingly, the thermal paste is grey, which I think means that someone's actually been in this machine and at least repasted the heatsink area. But everything so far is looking fairly clean. Nothing screaming out that, hey, this is obviously wrong. Check that. It's something adhesive. That's probably the residue from a liquid indicator, pH paper or whatever they're using. Litmus paper, rather. Yeah, that's happened here again, which means yeah, someone I think has been at this board. There's no reason for both of those tags to be missing. Can pop the can off here. See if there's anything under that. I mean, again, there's flux residue in there, but nothing that's obviously out of place. .3V42 looks fine. Okay. And flipping over to the back. Just looking for anything that's also discolored. Evidence of tracks heating up, or I'll just bring that in focus for you guys. Tracks or wires heating up, or the ends of any component terminals. The RAM area, again, there's flux staining in between the chips. So I think there's evidence of rework here. There's a cap down there that doesn't look too happy, but it should... it's not too bad, actually. We'll know if we have something wrong with the RAM, then that's probably where we'll look first. Again, there's foam has been damaged here, so yet more evidence for someone having been in this board or in this machine. 6259 looks clean. I didn't actually check the G3 hot rail on this yet, so that would be a dead giveaway for the SMC being on or off. slight corrosion behind the Thunderbolt port. So I think that's just surface. Can have a look at that. Okay, backlight driver, working fine. Ooh, hello. Okay, the SMC area doesn't look too fantastic. You can see there's a component missing there. I think that might be a capacitor. We'll check the schematic for that. I think that's the analog rail for the SMC, for the ADC reference, so we can check that as well. Top of that resistor does not look happy. You can see that most of the metal film on that has gone, so that's either going to be open or very, very far out of spec, whatever that component is. And I believe this is the reset controller. You can actually see there's a few components missing there, as well as the cap that doesn't look too healthy anymore, and these test points that are looking pretty unhealthy. So we'll flick over to the schematic. There's one other component missing here as well. So we'll flick over to the schematic and we'll have a look at what those are. And in the board view, that top part is R5115. I think that is the I think that's the soft power pad. Soft power button, rather. Yes. Okay. So, I mean, it's interesting why that has been ripped off. It's very, very clearly been damaged. There's no reason for that to be damaged, but it's not crucial for us to repair, so we'll check the next one below that, which is SMC reset. So it's the pull-up. That is a very critical component. So as it stands, our SMC is not going to be going to be in reset because that line's floating and it's most likely floating down. There's no pull-up on it. So we can have a look at what the value of that's supposed to be. Yep, 100K. So with that missing, SMC reset's going to be, this is an open collector output here. So this is going to, even if it's not being driven low, there's no pull-up source, so it'll be low. And have a look over to this chip, which I believe is actually that's not going to be the reset chip. That's going to be the RTC because we were just looking at the reset chip. So that one is U3540. No, not the RTC either. Sorry, that's the, what is that? That's a reset controller for airport, for the airport and Bluetooth card. Right, okay. Well, that one's not as critical, so let's start with the SMC. And we'll populate that pull-up resistor back in place. We'll have to do some pad repair there, because that is, yeah, that's not looking too fancy. And then we'll focus our attention on the reset. We also need to check, actually, while we're here, this resistor that's not looking too flash. And in focus. And That is going to be... Which one is that? This guy. Oh, also very critical. That one's R8115, which is something to do with PMS5 SLP. Yep. So let's have a look at what that's doing. That's 0 ohms, and let's have a look at what our actual resistance is. Hmm. 90 meg. Now, curiously, it raises the question why that has decided to go open circuit. So the right side of it here is the SLP S5 signal, and we'll just check that resistance to ground, which is 100K. And we'll check the other side of it, which is the S4 power enable. And that's around 90 meg as well. Now that seems quite low. Let's have a look at what we should be seeing for that one. Have a look at the schematic. So we've got it going to R8114 here. I'm not sure if that's populated by default. We'll just follow the S4 power enable signal. Which is here. Okay, so we've got it going into a FET, into a chip, into another chip, and then eventually it also works its way over to the PPV5 S4 RS3 regulator. Alright, so let's start by just addressing our pull-up problem. And we'll see if we can get the light on, at least on the MagSafe. And so our first little issue here is that we barely have any pad to connect to here, and absolutely, so the right side is the SMC reset line, and the left side is the 3V42. There's barely any pad to connect to. So if we have a look at the board view here, we can see that this signal, it likely comes up through the via and then attaches to this trace, or to this ball via an internal trace. There's a few other places that it goes on this side of the board, but it does go down here, which is near the ISL 6259. And our 3V42 also happens to go down here. So there's no reason why we can't just put that pull up between these two lines here. Functionally it'll be identical. So just to verify that, my mouse is going absolutely spastic there. There we go. Just to verify that, we'll just buzz out that trace is continuous to that point. 3V42 is pretty much guaranteed to be connected. There's no, it'll be run through an internal plane, so there's not much risk of that being open. And we do have continuity down near the ISL part, so to this resistor from this pad. So what we'll do is we'll drop a, probably, I think that's an 0201. I'll just check. Really? Yeah, that's an 0201. So an 0402 100K will do the trick there. Just double check that that is 100K that we're after. R5100. Yep, 100K. Perfect. So we'll refloat that into place. I'll just get rid of this, what's left of this phone tape on this side, just doesn't smoke while I'm reworking the area. Some fresh. Oh. That wasn't supposed to happen. Just grabbed the resistor. That looks horrendous, doesn't it? There we go. Not the prettiest thing, but it'll do the job. Good enough for the bush. Okay, so I'll just double check that we've got our 100K at that point now. So there is a test point just below it for 3V42 on R5117 here. So I'll measure from there to the right side pad. And we have 99.23K. And let's just check if we have our MagSafe light turning on now. And just plugging in the MagSafe. There we go. We have a green and then orange light. So of course fan is not spinning just yet. The core reason being that PM SLPS5 signal is still open. So we'll address that one next. And back under the microscope again. So I think I might just start off by taking that part off and replacing it at the risk of course, damaging the replacement part that I put on there as well. I'm just going to go get a 0-ohm jumper for that pad. Be right back. And we're back. Going to try to hand solder this, but I do have the hot air ready in case it absolutely fails. Let's see. Usually what I like to do is just anchor one side down, like that. Anchor the second side down as well. This tip actually needs to be replaced as well. The stubby conical is supposed to be a lot sharper than what you're seeing here. This is very much, I think I've been using this tip for almost 2 years now. There we go. It could have gone a lot worse. Yeah, the tip is supposed to be sharper, but it's still fairly forgiving because most of the thermal mass is further up on the tip anyway. It's fine for O201s to work down towards the tip, or rather, most of the thermal mass is up towards the elbow where the bend is. So, but for O201s, it's fine to work with the tip because there's not much to heat up, either pad or component-wise. And yeah, it doesn't look great, but it's fine. It's very obviously hand-soldered. Okay, so let's go ahead and check that part now, or the signal on that line. Just hook up the left I/O board. Alrighty. Okay, so we still don't have a fan spin, but that's okay. I would have been very surprised if that was the only thing wrong with it. We'll flip the board over. We'll just probe that signal that we reconnected. So we've got 3.3 volts on that side now. Oh, actually no, I spoke too soon. We do have fan spin. Very interesting. Okay, well, next thing to look at then is the airport reset area. Rebuild that because I suspect I think there's at least 2 parts missing there on the left, which is very interesting. Someone clearly knew enough to open this up, and you know, there's evidence of rework. It's curious why they would have just left those parts off. So let's just confirm that. Bring the board view up here. So I think R3553 here and 56. Bring the schematic up. And so 5335, that's a pull-up for the clock request signal input from the PCI Express line, and 56 is a 0-ohm jumper. Yeah, essentially connecting that clock request straight through, so right, okay, yes, so that will connect the output. I was about to say this is just directly shorting those 2 lines, but 3557, which should be in the middle of those 2, would be my guess, which it is a no-fit. So it connects the clock request signal to the CPU, I guess, or is that to the, yes, that's the CPU, and the input to the to this OR gate here. Cool. So yeah, we'll fit a 100K resistor on the top side and a 0-ohm resistor on the bottom side. Alrighty, and we're back with all our components. So let's just go and add some solder to these pads. And this guy here, we should check him as well. He seems to have a little bit of damage on his surface. Let me have a quick look on the schematic as to what that guy is. So 3554. Which is this 232K job here. Okay, so you get 100K one way, and check the other way. Probably measuring other resistances in parallel with that, so that's likely why it's reading low. And yeah, 90-ish the other way, so I think I'm going to call that good for now. He doesn't look too bad. I was just a little bit curious with the chip in on the right side there. So this capacitor will also need to replace. That's 100 nanofarad. So we'll do all of those in one hit. And I think I'll probably just end up using the hot air for this one, just to make short work of everything, and it'll also allow us to reflow this chip here, just to make sure that if there is any corrosion on those pins, which doesn't look to be, but we'll clean that up in one hit as well. Okay. Just clean up some of the expended flux there. And I'll put some fresh flux down. It's extremely hot down here at the moment, so the flux isn't doing too well. We're in the middle of some tropical storms. Okay, so the bottom side resistor, you can even see those pads. Just let that flux slightly. Bottom side resistor was 0 ohms. Do. And the top side one was 100K. And our capacitor on the right there was 100 nanofarads. I think I'm due for a refill soon. That'll do. Just turn down my air a little bit, maybe 20% or so. So I'm not blowing everything everywhere. Even still, capacitor has finished to drift. It's quite an unbalanced pad. The right side reflowed far quicker than the left did. Okay. Clean up some of our flux here. I usually need to do a couple of passes because while the board is still hot, the alcohol evaporates before it's had the chance to clean any of the flux off. And usually once you've gotten in there, after it's cooled a bit, it ends up looking a lot cleaner. I'll stick this through the ultrasonic once I verify that everything works anyway. So, alright, we'll put all this back together now and see if we get a working system with functioning Wi-Fi. Okay, so the board's back into the machine now. I haven't screwed everything in, just enough to keep everything in place. The battery's also not currently plugged in. So we'll power it up. We've got our green light, fan spin. But we do not have a chime. And no video on the display. So no post. Okay, so we're back under the microscope again. And usually the first thing that I like to check for machines that aren't posting is the SPI ROM area. So we can see there's a little bit of corrosion or surface corrosion on some of those test points there, but nothing's too serious. Like that's not. I mean, it'd be good to tin those pads, but we can check the continuity. I'm not expecting any problems there, so I'll just flip it into continuity mode. And we'll just go between this pin and this pin, and we do. And we have continuity on that one too. So I don't think that's the area that's causing this, not at this stage. The resistors all look fine, so the series ones that are going to the data and clock lines. So one thing that I did notice is this power regulator here has a little bit of corrosion on the pins there. So it might not be a bad idea to touch that up. But the main one that's caught my attention is there's a little bit of a blowout on this chip here. And this appears to be a power switch for the... let me bring up the schematic here. There we go. For 1V05 PCH HSIO. So I checked this, and we do have 5 volts coming into the chip, but we don't have any power coming out of it, and we also don't have an enable signal coming in. So we can see that's going into a FET here. That's a no stuff part. It's coming straight from the PCH. It's an output. And then there's a pull-up up to, let's see, where's that pulled up to? 3V3S0. And that's it. So given that there's very much a stain looking thing on the side of that, I think that chip is probably toasted. So I do have a board here that I can steal one of those from. That doesn't look too as gnarly, at least. There's a bit of dust and other crud around there, but that's what these donor boards look like. So we'll go ahead and take that chip off. So the other thing that I did is I measured the that enable signal to ground, so we can check on here. We can see that's that enable, and then it goes over to this, so that unpopulated FET pad here, which is Q8062. So if I probe between there and ground, we have 27 ohms. You can hear the continuity buzzer going there. So that tells me that in all likelihood, the enable input on this chip is shorted to ground. Or not shorted, but 27 ohms to ground. So we'll go ahead and take this off. And the pin runs on that side. We'll flip the chip over and have a look once we've pulled it off the board, just to confirm. But I'm not expecting this to look too healthy underneath. Should probably turn up my air a little bit. It's also probably helping that the heat sink's directly behind, the heat spreader is directly behind here. Which I have not taken off. Oh wow. So let's up the air here a little bit, 30%. Okay, that actually, well, the pad doesn't look too bad. Nor does the... This looks like a Dialog semiconductor part. Is that? Yes, it is. SLG5AP. It is a custom part. Dialog do make, at least for embedded applications, I haven't found anything that beats them in terms of package size, the low RDS on for the actual pass element, as well as the cost. They're hands down the cheapest parts that you can get for the IDS on that they actually provide, and the added bonus is that they are generally switchable to using a ridiculously low voltage enable signal, I think down to 0.9 volts. So it makes it perfect for switching high power rails, so 3 volts, 5 volts from low voltage CPU I/O. Just taking the chip off the donor board here. So highly recommend their parts. They have a really good sample program, I believe, as well. But their a lot of their parts are also regularly available on DigiKey. They do also have a high voltage line that are perfect actually for doing medium current, 10, 12, almost up to, I think they do range up to 24 volts switching. Again, they will enable using a ridiculously low 0.9 volt enable signal, and some of them even feature programmable current limiting and inrush or slew rate limiting as well. So extremely flexible parts for the price that you pay. Yeah, in general, very, very happy with them. They're usually my go-tos when I'm trying to spec something for an embedded design. Okay, just getting some fresh solder to these pads. Okay. I might just clean off the expanded flux there. Fresh flux down. Oh, actually, we should verify that that 27 ohms is gone now, because if it isn't, then that's game over, because that would mean our PCH is dead. And no continuity anymore, and we're reading 100K. Perfect. So, let's drop this chip on now. Come back here. You can see I'm very, very lazy with my alignment for this. I'm relying way too much on the solver mask to pull everything in. That's fine. I think just as a precaution, I'm going to hit the regulator that we looked at before as well, just because the one side of those pins looked a little bit corroded. Oop. Of course that's what's going to happen. Thought I'd give it a little nudge just to make sure it was in place, and heat takes it away. Sorry, the air takes it away. Okay, there we go. And that chip was just over to this side. Yeah. I think I might just try and hit it with the flux to start with. We'll just reflow that. Hopefully that's enough to clear out that corrosion. I think I might need to get in there with the iron, actually. If I can even reach. This is probably where I should switch to a new tip, because this one is very much on its way out. I got some fresh solder on there, a little bit more flux. And we'll just clean that up. Good enough for the bush. That looks horrendous. I'll get the brush in there. Marginally better. Not by much though. This will get ultrasonics again, so. Hey, that that actually cleaned up decently. Not too bad. Let's just check those joints. Oof. Yeah, okay, not fantastic. That second pin's going to need some attention because it doesn't look like it's connected, or at least not healthily. Might try and hit it from the front this time. Zoom in a little bit closer. Sorry about the focus there. There we go. That looks better. It always looks so much worse under magnification, and then you look at it without magnification, you can't even tell. There you go. So we'll drop this back into the enclosure again and see if we've made any progress. Actually, should just check that we're still reading 100K or so across that enable signal. And we are still at 100K. Perfect. Okay, so one thing I actually forgot to do just before installing it is check that we do have something. It's not a short across the output, but we do. There's 0.3 ohms between PP1V05 and ground. So we're going to need to locate that short and figure out if potentially that is a dead CPU or if the short is somewhere else. Okay, so interestingly, the regulator that we touched up is connected to the PP1V05 line, and it's generating the the high computing. Oh, hang on. Interesting. Yes, yeah, sorry. It's taking in PP5V S4 RS3 and generating the PP1V05S0 line. So I think we should try and just take this chip off and see if that makes our short disappear, because as they say, where there's smoke, there's fire. So get some flux on there. Hopefully not literally. We're almost there. The top side is reflowed because we replaced that with leaded solder, but remaining three sides, save for this middle pin, still waiting to reflow. And almost just this left corner. There we go. Okay. So let's check the state of our 1V05 line again. And we still have a short circuit. We're very, very close to. Now our pads all, land pattern all looks fine there. I'll just clean off the solder to see if we've got any tracking issues. It's remarkable how different the image quality is with a clean lens. There we are. So it all actually looks pretty good. Okay, well that chip's not going straight into the bin just yet then, because he might be okay. And we'll continue our search. Okay, so something unexpected happened. I hooked up a short test lead, just like, well, you know, scrap bit of wire to the 1V05, well, 1V05 net on that transistor, unpopulated transistor pad there, in preparation to just put some current through it and see if I could find where the short was with a thermal camera. And initially there was a decent amount of current, and then the fault seems to have cleared itself. So if I can get the probe in here, across the there we go. We now have about 5.6 ohms, which looks a lot more reasonable for a CPU rail. So I'm just going to I've put the regulator back on that we took off just on a hunch. So this guy here. And I'm gonna reinstall it and see if reinstall it into the enclosure and see if we've made any progress. Yep, so no good on this one, guys. I think the CPU is well and truly cooked. And I suspect whoever was here before me figured that out, which is why there was flux residue around the around those capacitors there. No fan spin even any longer. The enable signal for that load switch connecting the 1V05 to the HSIO rail is still fluttering around. So it's trying to enable something there, but yeah, there's I don't think there's any hope for this guy. Oh well, can't win them all.